Hello children, now we are going to discuss the resolving power of astronomical telescope. So astronomical telescope, as we have studied in ray optics, is an optical instrument which is used to get the images of the distant object, the celestial objects, the heavenly bodies, right? So any astronomical telescope, generally we use a bigger aperture and higher focal length lens for the objective, right? In ray optics also we have discussed that the objective lens, the size of the lens should be big, it should be large, because so that it can gather more light, and the aperture should also be big, right? So for a astronomical telescope, resolving power of an astronomical telescope is the ability to resolve the images of two distant objects. That could be star, that could be planet, that could be any celestial objects, right? So when the light is coming from the celestial object, let us consider the angular separation between two objects. Celestial objects is d theta, right? So we have discussed previously also that resolving power is given by 1.22, the limit of resolution is given by 1.22 lambda by the size of the aperture. So let us consider this is the objective lens, and light of wavelength lambda is falling on the objective lens of the telescope, right? Let us say the size of the telescope is A. So here we denote the size of the aperture as the diameter of the objective lens of telescope. So what is the size of aperture here? It is the diameter, right? So we have learned that the limit of resolution delta theta or d theta is given by 1.22 lambda upon the size of aperture. So the angular separation between any two stars will be 1.22 lambda upon the size of aperture. What is aperture here? D is aperture here, right? And resolving power is the reciprocal of the limit of resolution. Limit of resolution is this in terms of angle. Limit of resolution can be in terms of angle as well as in terms of distance. So for compound microscope we take in terms of distance, for telescope we take in terms of angular separation, right? So it is inversely proportional to the limit of resolution. This is limit of resolution, which we may also say it is in the form of angular separation, right? So resolving power is a reciprocal of d theta, so this inverts and it becomes d upon 1.22 lambda. So resolving power of an astronomical telescope depends on the diameter of the telescope and the wavelength of light used, right? So if suppose we want a telescope whose resolving power is high, so what we will check when we will purchase a telescope? Its diameter should be big, right? If diameter is large, resolving power will be large. If lambda used in the observation is small, then resolving power will also be high. In order to get a better resolving power, we reduce the wavelength, and 1.22 is here a constant from the standard expression, right? Thank you children.